All right, afternoon, everybody. Thanks for joining in. Uh, this week we have Steve Wallace, who's going to be going over a lot of the work that he's been working on for probably about the past year or so, right, Steve? Working with CADA and trying to develop some better tools to help us get more information out of our routing infrastructure. So there's going to be some demos and a little bit of a talk. And Steve said, certainly raise your hand or ask questions in the chat room if you have them. So I'll turn it over to Steve.
Thanks, everybody. For those of you who don't know me, my name is Steve Wallace, and I work for Internet2, and I'm the Director of Routing Integrity for Internet2. And today we're going to talk about Project ROOTBEER. ROOTBEER is actually an acronym, Routing Operations Observational Technology Building to Enable Education and Research. I think CADA can take credit for that acronym. It's a partnership between CADA and Internet2, and talk a little bit about that partnership. It's supported in part by a National Science Foundation award. And the key contributors from Internet2 are James Deaton, Jeff Bartig, Carl Newell, and myself, and from CADA, Casey, and Matthew Lucky. So intentional routing is when data takes the desired paths. In other words, it's doing what you expect, and generally for research and education data flows, it's best to keep those flows on the R&E infrastructure and the optimal R&E infrastructure, and to keep the commodity traffic on the commodity infrastructure. There are a set of tools that we're building or have built that relate to intentional routing. So we have a way of measuring routing policy, whether people choose to prefer R&E routes. And we also have some topology visualization stuff. So the measure routing policy is kind of done. The topology visualization is half done, and I'll show you some of that. We believe we can use the same infrastructure we built to measure routing policy to also detect potential route leaks from the community. And part of one goal, the longer term goal of the project, is to build a system to manage a list of prefixes. These prefixes would be the IP prefixes that represent the global research and education community. And so they could be used as sort of universal filters on routers, and that would be a dynamic list. And so our goal is to build a system that can manage that list effectively enough that we can put it to use. Routing security, sort of manners stuff, help to diffuse routing security practices such as AS-set-based filters, RPKI ROAs, and sort of newly RPKI ASPAs. And we have tools that we built to measure the deployment of ROAs and ASPAs. And we have also built tools to help people with building their ASPAs and building AS sets. So one of the things we built, which is a little unusual, is the system to measure the routing policy of remote networks. So the system sits in a facility at Internet2, and it's dual homed. And so it's a physical interface that is connected to the research and education network, and an interface connected to the commodity network. And it has 3 different loopback subnets and IP addresses. And those subnets are announced differently to the commodity and the research and education network. So for example, one of the subnets for one of the loopbacks is announced to R&E prepended. So we make that route less attractive than the commodity route. So if we send a measurement probe, and I'll describe those in a minute, if we send a measurement probe from the loopback address where we prepended its subnet towards R&E, and the response comes back over R&E, we know that the target network is likely using local pref to prefer R&E routes even when they have a longer AS path. We have an IP address and subnet where we don't do prepending in either direction. And then we have one where we do prepending towards commodity to see if there are networks that actually prefer commodity, and there are. And then we have a third address. We have another address where we can detect if the target network is taking a default route from the internet. So we announce a more specific covering route to the commodity and a less specific to R&E. And so we could detect those cases where a network maybe takes the R&E routes, but just points default out to commodity. We've been working with CADA on some research to determine the effect of only taking a default route. And there is a measurable effect. In other words, there are parts of the internet that are unreachable if you do that, and you make parts of yourself unreachable to the internet if you do that. And we've submitted a paper to IMC detailing the results of that. So that's one of the things we can test with this infrastructure. I'm not going to go over how this infrastructure works much more. If you have questions about it, probably good to ask them now. Tick tock, tick tock. No questions about this. Okay. We're going to test some tools, and we'll see how this works. These are actual links in the slide deck. So we have a tool called the Local Pref Probe. It's sort of an on-demand tool, and we're going to go ahead and use it. By the way, if you go to rootbeer.internet2.edu, you'll see all the tools and descriptions of all the tools. But here's the tool we invoked. Most of these tools, if you're looking at something, it changes the URL, so you can pass the URL off to someone else and they can see the same thing you're looking at. So here is, I think this is SDSC. So this is a subnet within San Diego Supercomputing Center. And the probes we send are ping packets. We get a list of responsive IP addresses from ISI. And so in this on-demand probe, you enter a target network you want to test, and it picks up to 5 responsive addresses within that network. It sends pings from each of these loopback addresses to those responsive addresses and records what interface they return on. In this case, they're all returning on the R&E network, which implies that this network points default to commodity and takes an R&E table. In addition to, and so that's how packets return to the probe. We also pick about a dozen ARC vantage points that sit within the R&E infrastructure, and we do a trace to one of the targets of the probe to see what that looks like. And the ASs are green if they're part of the R&E infrastructure, and they show up red if they're likely not part of the R&E infrastructure. And you can click on any of the leafs and see the full trace it did. So this is kind of nice if you want to test one network. Right now, it works for v4. We're getting ready to do v6 implementation, so we'll have both. But the first one we did was for v4. I'll show you a couple more examples. Here's a classic one where usually, we'll see what the results say. So here's a network at Indiana University, and you can see it gets a full commodity feed, and it prefers local prefs R&E networks. And here's a network. I think this is in Egypt. It's part of the R&E infrastructure, but it actually prefers commodity routes. So this does happen. We don't see it that often. There are sites in the US that do this. Sometimes those are, we've identified one school recently where it's just a misconfiguration and it was something that they were unaware of. And so this tool measures it. So if you, sorry, I'm bouncing around here. Yeah, global, okay. So we have this tool, and on demand, you can do these tests and measure the routing policy of the remote network. And every night, we probe all the networks in the internet with that tool. And the probes that we send to the R&E community, and there are about 18,000 V4 routes and 2,700 ASs that make up the research and the global research and education community. So we actually ping everything in the internet every night, and then we take those results for the R&E community, and we produce this report. And so the way this report works is that I don't know why this is AS1. That's because the window's not wide enough. There we go. So this report is organized by the top level is Internet2's AS 11537. And then underneath that are all the direct peers with Internet2. So that includes all Internet2's customers in the US, the FedNets, and international peers. And on the right, there's this graph. And the graph right now is depicting for this AS, let's say the top one, the Internet2 AS, for that AS and all its children, what percentage of probes that determine routing policy showed local pref versus ones that showed the AS path that determines the path, AS path length, or they prefer commodity. So if you look at, and this is actually the entire global R&E environment is aggregated under this one top node, and about 84 or 81% of those networks appear to prefer local pref. But a chunk of them, 12% actually prefer commodity. So kind of a curiosity. You can dive down in here. So let's see, NCRN. So this bar represents for NCRN and all its children. And there are 192 prefixes in all its children. But then you can drill down and you can see, oh, okay, so this particular university appears to have their routing policy set up so that the path chosen is determined by the AS path length. In other words, they don't prefer R&E or prefer commodity. Also tells you a little bit about that prefix. If you click on the bar graph, it will give you a more complete description of what it finds for that particular AS and its children. So this is a good way, and you can search for stuff. So, if I'm interested in, I don't know, ESNet, I can jump to ESNet and look at their peers and see, which ones are preferring R&E routes, preferring commodity routes, or letting the AS path length determine this. You can sort by potentially interesting things. So if you hit that, it basically brings the more interesting stuff near the top. And you can also sort by address family. But for this particular measurement, currently we're just doing V4. We're working on V6. So there are other metrics that this can display. And really, this report tries to display the things that affect routing policy one way or the other. So local pref is a hammer to override AS path in the route selection. and this measures local pref. We can also look at more specifics. And the rest of these work for V6 and V4. And this graph is showing for, and it's sorting by IPv4. It's showing what percentage of the V6 or V4 addresses for this AS and all its children have more specific routes in the commodity internet. So if we choose this AS, it looks like that for IPv4 space, for the total space for this and all its children, about 53% of that address space has more specifics in the commodity internet. We can drill down and take a look at that. And there's reasons for this. New Jersey Institute of Technology, and they have a /16, and they announced the 16 to R&E, and they announce all these more specifics to the commodity. Now, I'm going to guess that they have an always-on scrubbing service. And so typically when we see this, especially if it's a large chunk of the address space, they'll be using, a Cloudflare or some other company's always-on DDoS scrubbing service that works by ensuring that the traffic towards the campus goes to their cloud scrubbing machines. But again, this is one of those things that can determine what your routing policy is. And so that's one of the things that we depict in this report. And again, it does it for all of the networks, the FedNets, our international peers like Géant. It does it for all of them. And you can drill down and look at all these networks and see them with as much granularity as you want. Always the bar on the right is whatever is in the row, it's everything in that row. And if it has children, all the children all rolled up together. So if you want to get the values for an individual AS, you need to drill down to that AS, and then the bar graph represents just that AS because there's no children. You click on the prefixes, and it tells you pertinent information about those prefixes. So any questions so far? Okay. So local pref, more specifics. The other sort of route policy thing is AS path prepending. And let me collapse all this back so it's easier to read. And I still have put potential issues at the top. And so this metric is the percentage of IP space that is affected by AS path prepending. In other words, the routes that Internet2 receives have AS prepending in them towards Internet2. So let's take a look at this one. And so these 9 prefixes. So this AS is originating these 9 prefixes, and you can see that they're prepending an extra origin. Oh, actually, it's not the origin. It's a network in the middle. They're prepending that to make that network look less enticing to whoever's receiving these with prepends. So this is another thing that influences routing policy. So this is a way to sort of sort things to the top, make them easier to find, drill down, and look at the things that impact routing policy for these networks. We're going to add networks that take default routes. That's not in here yet. And so that'll make 4 things that affect routing policy. And then the other 2 measure elements of routing security. So if you pick RPK ROAs, it shows you per AS. And again, this would be, if the AS has children, these percentages reflect all the prefixes of all the children. And this metric is what percentage of the IP addresses and the routes we receive from this peer are covered by ROAs. And green is they are covered, and the sort of gray is they're not covered, they're unknown status. If we receive one that's invalid, it will show up here, but the way I get the routes for this tool today, that's probably never going to happen because the policies of the network between the collector and the routes is going to prohibit those from showing up. We have another tool where that's not true, but it is true here. So if you look at the global R&E environment for v4, about 40% of those addresses are covered by ROAs. Now, there are a couple of controls up here that I haven't shown, and I can take the FedNet routes out and the international routes out, and you can see the ROA coverage. So this basically is the Internet2 participants drops to about 30%. So let me put those back in. And Autonomous System Provider Authorization is another RPKI object to improve routing security. It's relatively new. There are a few networks in Internet2 that have ASPAs. It's relatively straightforward. If you have an autonomous system, to make an ASPA, you go into your RIR. So for us, it would be Aaron, and you list the ASs of your service providers. Dale Carter did a fantastic webinar on how ASPAs work. I highly recommend. It was done for the routing working group, and Hans has a link to the video. So if anybody's interested in this, I would encourage you to take a look at it. Right now, the deployment is pretty small, although in Europe it's better. So in our neck of the woods, it will overall globally, it's less than 1%. If I take out U.S. networks and Fed networks, it climbs a little bit. If I just looked at GEONT, it climbs higher. But this measures, and this metric and because it's for AS, it's not address families. There's not a V6 or a V4 component. And this represents the percentage of ASs from this peer and all their children that are covered, that have ASPAs that list service providers. So that's this tool. You can search in the tool. There's a pretty good about page, pretty detailed about page that describes what it's doing and how to interpret the numbers. And there's actually a tour, which is not bad. I probably need to update it a little bit. You can also look at older versions of this report. So any questions about this report before we move on?
Nothing in the chat room.
Okay. The report's updated daily. Yeah, so that's that one. All right. Next thing is we're gonna look at the, let me go back here. Sorry. We're gonna go to the topology report. This is new. This is brand new. And the data in this report is a few weeks old. It's possible by the end of the day, certainly by Monday, I will have the machinery in place that updates this data on a daily basis. This data is different than the other data. So we're taking all of the routes that are announced to Internet2 by all of the peers, and we're getting those routes before any policies are applied to them. So in the last report, we were only seeing the best paths that were used in that report, rather than all the ways to get to something that we see. So, it's common for, especially in the R&E environment, for a backbone like Internet2 to get the same route essentially from many different peers, and we digest that into the best route, and that's usually what's fed to a route collector. This tool we scrape the routing tables, not even routing tables, the routes received from each BGP peer on every single router in the network once a day. And we use them to compile this report. Similarly to the last report, it's organized by AS that peers with Internet2. And you can drill down into the children, or you can just click on one, and here's CERNs. And so the way to read this report is that routes are flowing from left to right. So this is not a traffic graph at all. It just shows you where the routes are coming from. And so in this view, CERN is here, and it will detect things upstream of CERN. And Internet2 is the last thing we see here. You can click on parts of this and see details about that particular AS, which routes they're sending, which routes are originating from them, which ones are transiting them. So what this shows is that Internet2 has a lot of different ways to get to CERN. We peer with them directly over this orange path. It's kind of hard to tell that. We also get the routes from CERN. We also get the routes from StarTAP, and we get some of the routes from MRAN. If I was interested in knowing if I want to know the path we're likely using, I can hit best path only and simplify that diagram. And so, we're using Giant to get to CERN, it looks like. This is a new tool, so it probably is going to rapidly evolve, and there are probably some bugs in it. You can download the diagram as an SVG just by clicking this button. So CERN is an interesting one. There are, let's see here. Karen Andrew Gallo has fixed this, but this is an interesting thing that shows up in this report. Let me make a little more room for this graph. So in this graph, you see we're receiving 2 routes from Karen that we're rejecting. And you can click on that and see here are the 2 that we're rejecting up here. And if you look at this, these are routes that are coming to Karen from I2PX, and they're actually coming from commercial providers. So these are commercial providers where Andrew had accidentally applied the wrong policy to them, and it resulted to them being leaked to Internet2. Now, we rejected them, so no harm here. But he saw this, and the picture was much easier to interpret. And there's another one of these. I haven't talked to those people yet, but there's another one of these just like this, where it just jumps off the page that there's a route leak from a commercial provider and they're announcing it to Internet2 and probably announcing it to other people as well. This data I said is a few weeks old, so if this was current data, it would not be showing this. So this one's big. This is APAN-JP, and it's kind of cool because it shows all of the ASs behind that connection, and it just goes on and on and on. I won't go through them all, and it shows you that all the different ways we see routes from them. And then again, I can hit just show me the best paths, and it greatly simplifies the view. But if I'm interested in understanding all the paths, so for example, let's say I want to understand the resiliency, what are things that exist that I could use? They're here. I'll show you another one. ESNet has an interesting thing. So again, Internet2 is on the right, routes move from left to right. So ESNet announces their routes to Singarin, and Singarin announces them to APAN-JP, and APAN-JP announces them to us. So we have a couple ways to get to ESNet, including via Japan. Now, if I say, just show me the best path. We don't use that route. um, but um, but that topology exists, and it probably shouldn't exist. And now that we have tools like this, it probably will help us design uh, routing policies that do what we want them to do. I mean, that's the purpose of this tool, is to sort of see your routing policy. Okay, any questions about this tool before we move on? No questions. Okay. All right.
Nothing in the chat room.
Nothing in the chat room. All right. So we're going to go to the ROA planner. And we started working on these tools with Kata in October. But before October, part of my job is helping people with their ROAs. And I had developed some internal tools. They weren't web-based. They were just Python scripts that produce Excel files that outputted. And so I got kind of used to figuring out what data is useful to help better understand what the ROA needs are. And sometimes those needs are microsonata. I believe that Singaran provides some transit TSF information. Is intentional. Okay. So this tool looks up current routes seen in the internet. So you give it a prefix, and it looks for related routes seen in the current internet. It looks at routing history from RIPE. So it looks back in time to see what routes have existed in the past. And it also looks for internet routing registry route objects to see what route objects exist that suggest a route. And it takes all of that information, and it also takes the registry information and breaks the prefix down by its suballocations. And it takes all that information, looks at any existing ROAs, and then gives you essentially a list that says if you assume the routes in the past, the current routes, and routes represented by route objects, those all represent potential routes. It'll show you candidate ROAs that match all of those, and it will show you them in multi-prefix form, because you can have a ROA that has multiple prefixes, or sort of single prefix form. This is a case where this is a prefix that ORNet uses, and they assign parts of this prefix to different customers. So creating a ROA for something like this can be complicated, because it's probably not the case for ORNet, but some organizations might not have accurate records on who they signed to what or where. And so this looks up the routing history, the registry information, and just assumes that it will apply all of it to give you a list of ROAs that will cover it. And then you can go in and you can uncheck things. You can say, well, this IRR entry, don't think about that. Don't consider that. In this piece of routing history, don't consider that. And it will recalculate the set of candidate ROAs to not include those. So let me describe a couple cases where this has been a lifesaver. So I've helped one organization make ROAs where apparently every year they have an event offsite, and they take some of their address space and they announce a more specific offsite. And when they were sitting down and we were talking about the ROAs, I showed them, hey, it looks like 5 months ago you were announcing a /24 out of your 16. And they're like, oh yeah, I forgot about that. We do this thing offsite. And so, this tool ensured that they made a ROA that included what they needed to include in the ROAs to make sure the next time they did that, it worked. We've had another case where our organization had a DR site that announced a more specific from a different origin. And there was evidence of that in routing history. And so That would have been a disaster if they had a ROA that didn't allow their DR site to announce its address when needed. So those were two saves. And the other thing is sometimes there are route objects that hint that you have a on-demand DDoS scrubbing service and need to be mindful to ensure that your ROAs accommodate however they're going to announce your addresses when there's an issue. Now, no tool is perfect. When you use this tool for the first time, a disclaimer comes up and says, if you put the row in wrong, you could lose your connectivity, and you need to use this tool for input. It provides good input, but somebody needs to be responsible for the configuration they're setting up in their row. Any questions about this tool? No. Okay. We have an AS set planner, and I'm going to show you kind of a complicated example. So this is something to help R&E networks only with making AS sets that they're going to use for R&E networks to do filtering. And the reason I say that is its view of the routing table is just the R&E table. And so it will look at your downstreams. It will make a candidate AS set that shows, for the current snapshot, what the downstreams are of an AS. And you can also have it compare it with an existing AS set. So in this case, I picked an AS. I think that's a Red Clare AS. And then I also asked to compare it with the AS that they publish. And it will show you how the membership of these AS sets overlap or don't overlap. It'll show you the members of the AS set as it sees your downstreams, and it will also show you a hierarchy, a simple text graph that shows you the hierarchy of you and your downstreams. Any questions about this tool? Okay. We also have an ASPA planner. Now, the ASPA planner seems to work reasonably well for networks at the edge of the internet. It's difficult to get an authoritative list of AS set relationships. So we use data published by CADA that shows AS set relationships, who's a provider, who's a customer. And it's not perfect data. We also use routing data from RIPE, and we try to infer what an ASPA would be. I'm going to put in a network that I know, and it's not going to have much of an ASPA, but it will get me to another AS that has more of one. So this is the Indiana Gigapop, and they have one provider. This is Indiana University campus, Bloomington Campus Network AS87, and their provider is the Indiana Gigapop. So if they made an ASPA, it would be this simple. But let's put the Gigapop's AS in there. And here it shows their peers, and it categorizes them as to whether they're a provider or not, likely provider or not. It shows a diagram depicting that, and it shows them sort of what the ASPA would look like, the list of those providers. This tool is to help people get started with making their ASPA. There are just too many limitations for people to blindly use this. I have warnings all over the place, but it is useful, and for networks not near the edge, especially the R&E environment, it seems to work pretty well. but it doesn't work perfectly. And so I have a concern that people should not use this blindly. They just need to use this to help them understand what ASPAs are, and get some information to start their ASPA planning for. Any questions about this tool? Okay. I'm going to show one more tool, sort of tool. Where is it? Da-da-da. Global ASPA coverage. Okay. So ASPAs are relatively new. This depicts every one of these circles or diamonds is an AS with an ASPA, or an ASPA is pointing at it as a service provider, one of the two. And the size reflects how many customers and how many customers point to it and how many providers do they point to. So if you add those numbers together, that's what determines the size in this diagram. The relative position is determined roughly by the compass heading from the center of the US. So the stuff on the right is sort of Europe. The stuff lower right is like Africa. Left is Asia. You can filter these by region. So if I took out Europe, you can see it kind of disappears. If I took out Africa, oops, some disappear there. There are some basic statistics, like for, well, let me get back. We define something called an ASPA rank. And an ASPA rank is how you would order the ASs that either list providers or are listed as a provider, how you would rank those, actually providers. They have to list a provider. If you walked their customer to customer to customer relationship all the way down, and fanned out, how many ASs would be in that cone. So I call that the ASPA cone, and the ASPA rank is your relative cone value for an AS. You can search for ASPAs. So if I search for Internet2s, Internet2, oops, 11.537, I can type. So there are two networks that peer with Internet2 that have ASPAs that list Internet2 as a provider. Internet2 hasn't made any ASPAs yet. It's a little bit of work to figure out what would be the proper set of ASPA, proper set of providers. I think for Internet2, it's going to be almost a complete list of all our peers. But here's an example, so I can open this one up. And so this is MoreNet. Go MoreNet. Very few people have ASPAs. So, and these are the providers that MoreNet is listed, and you get a list of providers over here. So they've created an ASPA that lists those providers. You can look at, let's see, we'll pick a big one. Here is Cogent. And you can also say, show me their entire ASPA cone. And you can trim this down to show just sort of their direct customer provider relationships. And you can click on any one of them and see it. I think the search is probably the most useful thing here. It was kind of a fun thing to do. This was a weekend project to produce this. So, any questions about this tool? All right. I believe that is the list of tools I had to share.
All right, thank you so much for going through all of that, Steve. Uh, I guess if anybody does have any other questions or wants Steve to name or shame anybody in particular, he can pull up the interface again and we can do some deep diving. I mean, I had a couple of, questions that I had jotted down. What was the most interesting thing that this tool has shown you so far? And, hopefully it led to a fix if it was something that was egregious.
So we identified a school, a research school, who was preferring commodity over internet. And then when we looked at our flow data to make sure, right, that we were detecting correctly, we saw some other interesting artifacts. So they have something kind of odd going on, and we've reached out to give them some help with that. Um, the when I first produced those pretty graphs that show the rich topology, all the routes we receive, um, uh, Andrew Gallo almost immediately said, "Oh no, um, I didn't realize that," and fixed his route leak. Um, when we added AS prepending to the global uh, uh, local Pref Probe report, Dale Carter from ESNet let us know that we were wrong, and it turned out we weren't wrong. That one of the networks behind ESNet is upgrading the routers, and so apparently they were sending us the community for graceful shutdown. And when we receive routes with graceful shutdown, the policy of the Internet2 network is to prepend some ASs there so that other routes would look more attractive and it would be a smoother transition. And so it was pretty interesting. So Dale's a great guy. I don't know if he's here or not. He's been very helpful. But he sends us his outbound routes and says, "See, I'm not prepending anything." And Jeff Bartig was the one who recognized what was going on, and so that was interesting. Um, I've had Richard, drawing a blank on his last name, one of the chief engineers for Canary, say that they are using the local Pref Probe report with their provincial networks to work out some issues. We're going to have a BOF at TNC in June, and one of the items that we have on the agenda is to invite other networks to share their pre-policy routing data so that, actually, let me bring this up really quick and show you what we'd like to be able to do. Here. Okay, so this is our connection with Jan, and it's it's got a lot behind it. I guess Jan's not that interesting, but the idea would be that this display ends at Internet2, so the routes are going left to right. And wouldn't it be great if they continue going left to right from Internet2 to another peer? I'm not sure exactly. We haven't designed how this would look, but imagine there was another bar for Géant here, and it was showing, excuse me, this bar for Internet2, and it's showing Internet2 routes going to Géant, and Géant would appear somewhere on the right. And we would see all the ways Géant receives our routes. And so that's what's missing from this picture. This picture is showing us how we receive routes from Géant. It's not showing how Géant receives routes from us. So to get the symmetric picture, which I think could be revealing in some cases, this might not be as interesting, this one, but others would be. We're going to see if there's a way that we can structure something if for those networks that would like to have that more complete picture, we can integrate additional data and provide a more complete picture. So those are some of the things. Plus, it's just been fun to look. I really like looking at this particular, um, uh, just seeing different connectivity, what it looks like. Some of it's pretty fascinating. uh, uh, so
All right. Does anybody have any questions for Steve?
Steve, I'll make a comment here more than a question, but I was the looking at one of our subnets. I was trying to figure out, well, why is this one problematic? So I noticed that we were announcing, this is a /24, we were announcing some more specifics to commodity. But then I looked at the Lumen Looking Glass, and they were in fact accepting these more specifics of the /24, which I thought was very odd.
so you say they were or were not?
They were.
So we get we uh, we get the commodity. I'm trying to remember. We get it from. Yeah, that is odd. You would think that they would limit that to a 24, and we get the commodity data from route views. I forget. We may get it specifically from the Lumen feed. I can't remember exactly which point we get it, and so that may be where we get it.
But when I noticed that, I did tighten up the filter to stop announcing the more specifics.
Internet2 will accept those. I think up to 27. But it's weird that Lumen was.
Yeah,
I guess maybe people do that for TE within Lumen.
could be.
Any other questions?
Hey, this is Andrew. So first of all, thank you for pointing out that I did fix the the problem. When you first said I'm going to click on Karen, I'm like, oh God, please no, please no. All joking aside, that was exactly what that tool was for. Steve sent me a message saying a picture's worth 1,000 words, and I said I can think of two, and they begin with O and they end with an exclamation mark. Um, I apologize if I had to meant to, if this was asked, I had to jump off quick. In any of your path analysis, do you plan on comparing V4 to V6 and showing any differences between the two protocols?
That's a good point. I had not. Um, uh, so the paths that show up in the topology stuff include V6 and V4, and it would not be hard, I'm pretty sure, to color them or to otherwise differentiate them. We could do that. Yeah. So the topo, first of all these things need new names. They're terrible names, and the user interfaces all look different, which is a problem. We're going to work on that. But the R&E topology report, the one that produced the graph that was worth 1,000 words, I think it would not be too hard for me to visually differentiate the V6 paths from the V4 paths. I'll look into that.
Cool,
All
thank you.
right. Does anybody have anything else? All right. Thanks so much, Steve. Um, just as a note on the next talk, it won't be till the end of the month. So we will have Personar development team office hours on the 29th. So hope everybody has a good couple of weeks, and we'll talk to y'all soon.